I'm going to infer some labeling, some vector z on these, and perhaps these are the 4 colors that I label. You can see here that these are sort of large contiguous blocks, and that then defines this inferred matrix M, in which I see a lot of density, so a high probability of connection along the diagonal. That means that like tends to link with like. So the purple vertices tend to connect with each other, and not as much with the green or the blue or the orange, and that represents this large density up here in the purple-purple block. So this gives us an interpretable way of compressing the data, of understanding how these different groups connect to each other. Okay. There are, of course, lots of other different ways I can represent the structure of the graph within this framework. So this is what we would call assortative structure, in which like links with like. But that's not the only way we can structure this matrix. We could also have the density be off the diagonal, and that would be what we call disassortative structure. Like links with dislike. So purple vertices tend not to connect to other purples, but only to other oranges or greens or blues. Or we could have that there's some sort of ordering on those colors. So instead of colors, perhaps this is like class year, freshman, sophomore, junior, senior, in which case we'd expect that the freshmen would probably interact with other freshmen, and maybe with a few sophomores that they interact with in their classes. The sophomores might talk to freshmen and juniors, and the seniors would probably talk to nobody except each other. That's how seniors work. So that would give you this nice linear ordering on the colors. So no longer they're colors, now they're numbers or some sort of ordinal value. And then you might get some sort of order structure like this, in which you have seniors, juniors, sophomores, freshmen, and high schoolers. And the final sort of large, stylized version of large-scale structure that we talk about is this notion of core periphery, in which now we have this sort of onion shape, in which we have a dense core. They tend to talk to each other. And then there's a group of vertices that talk to them and to each other a little bit. And then there's another layer outside of that that talks to each other even less, but talks to the core a little bit more. And that gives you this kind of structure here, in which the green and blue vertices tend to be in the middle, and the magenta